given a number in the decimal system, how do you convert that into binary, octal, and hex? So for example, if the given number is 53.625, that is the decimal value or the base 10, how do you convert this into binary, how do you convert this into octal, and how do you convert this into hex? So let's take the decimal to binary part. So the given number is 53.625, and we would like to convert this into its binary equivalent. So there are two parts to this. The first part is where we have to deal with the non-fractional part, and the second part is where we have to deal with the fractional part. So let's deal with the non-fractional part first. So we take 53 and we divide it by 2. So that's 26 with the remainder 1. We keep doing this. 13 with the remainder 0. 6 with the remainder 1. 3 with the remainder 0. 1 with the remainder 1. And 0 with the remainder 1. So once you get a 0 here, that is where we stop. And this will be the MSB, or the most significant bit, and this would be the LSB, or the least significant bit. So the equivalent binary would be, that is for the non-fractional part. So we go from bottom to top. So that's 1, 1, 0, 1, 0, 1. Okay, now let's look at the fractional part. So you had 0.625, that's the fractional part. So you multiply it by 2, so you get 1.25. So this one would be a minus 1, and then you take 0.25, you multiply it by 2, you get 0.5. So this one would be a minus 2, and then you take 0.5 and you multiply it by 2, you would get 1.0, and this one would be a minus 3. So going back to this one would be a0, this one would be a1, a2, a3, a4, and a5. So the final decimal equivalent would be this one, that is 110101 point a minus 1, a minus 2, a minus 3. So that is 101. Now let us try the same thing with the octal system. So we have decimal to octal given 53.625. We need to find its octal equivalent. So the process is similar to decimal to binary, except that now we deal with 8. So let's take the non-fractional part, 53 divided by 8, 8 6 48 with the remainder 5, 8 0 6, and we go from bottom to top, so that would be 65. Now we have to deal with the fractional part, so that's 0.625 times 8, that would be a 0, That would be another 0, 8648. That's 250. So this one would be a minus 1. Therefore, the octal equivalent would be 65.5. Now let's go for the decimal to hex conversion. So given 53.625 base 10, we convert it into base 16. The process is the same. So take the non-fractional part divided by 16. 16 3s 48. Left with the remainder 5. 16 0 3. So that's 35. Now let's take the fractional part, which will be 0.625 times 16. So 16 5s 90, 16 2s 32, that will be 41, 16 6 96, 96 plus 4 is 100. So that's 10.010. Now remember, in hex 10 is represented as A. So this is A minus 1, which is equals to A. So the equivalent hex number is 35.8. So with this we are done with the decimal to binary, octal and hex equivalent conversions.